Good day, folks. Let's look at the electrolytic process, which is called decomposition of copper chloride. The decomposition of copper chloride, that means we're splitting this into iron using the energy. So here in this solution, we have a copper chloride, but it is copper chloride, it's dissolved in water, but we're splitting this using the energy, right? So what is happening here? If you look at the copper chloride, it's an ionic compound in a solid state, and when we dissolve it in water, so in the electrolytic process, it's split into copper 2 plus in an aqueous state, and then plus the chloride, but two of them, chloride ion in an aqueous state, right? So if we look at this solution here, the solution that we have here, it's a solution of these free moving ions. So we have the chloride ions and the copper ions, but there are a lot of them. It's not only two of them. So guys, if you look at the terminals of the battery, we have the positive this side, and this type of an electrode is connected to the positive. So if it's connected to the positive, that tells us this is an what? This is an anode, right? And the negative terminal of the battery is connected to the side of the electrode. So that means that this one is a cathode, right? So now what is happening here, guys? What is happening, as I've mentioned in the previous video, that, okay, let me tell you this before I forget. These types of electrode, guys, are called carbon graphites. And the carbon graphites, I've covered them, guys, in the previous video. They are inert, and they are there for electrical conductivity. So they are not there for redox to be oxidized or to be reduced. Okay, so what is happening here, guys? Basically what is happening here, the electrons are transferred from the anode to the cathode there. So this one, as it transfers the electrons there, it will become positive, positive, positive. Forget about these bubbles for now. Let's pretend that they are not there. Even this reddish brown color is not there in the meantime. So what is happening, as I've mentioned in the previous video, even on the galvanic, that the N ions, which is the negatives are attracted to the anode, right? They are attracted to the anode. So when these negative are attracted to the anode there, what is going to happen? The anion is going to move to the anode. So what is going to happen there? The chlorine will donate electrons and oxidize. So what's going to happen there? The chlorine, once it is attracted there and donates electron and oxidize, that means in this side, in the anode, this is what is going to happen. The chloride ion, which is, it's two of them, it's going to oxidize into gas and two electrons, which means this gas that is formed here, this gas, it's going to be these bubbles, right? These bubbles. So these bubbles in color, guys, you can see they are yellowish green. They are yellowish green with the sharp scent. In terms of smell, they have a sharp smell. Those bubbles there, that's the chlorine. Remember, guys, what I'm saying here, this electrolyte, it consists of free moving ion, which is the positive and negative, which the N ions, which is the negative, are attracted to that positive electrode there, right? Because it releases the electron, it becomes positive. So those chloride ion are going to be attracted there. So what are they going to do? They're going to donate electrons there. So in they donate electrons there, which means they become what? Oxidized. This is what is going to happen. It will form a gas, and these gas bubbles that are here, they are yellowish green in color with the sharp scent, which is the sharp smell. right? And yeah, so here we have that, we have that. But now let's look at an anode. What's happening to an anode in this side? Let's look at it, not an anode, in the cathode in this side. So in the cathode in this side, let's pretend as if this is not there yet. So what is going to happen here, guys, is this type of an electrode, which is the carbon graphite, gains the electrons, it become negative, 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 and the copper ions there are going to be attracted there. All the copper ions that are there are going to be attracted there. So those copper ions that are there, they're going to gain these electrons. So they're going to be reduced and gain these electrons. This is what is going to happen there. It's a Cu2 plus the two electrons, and then they become what? The copper in a solid state, which is this copper here, it's in a solid state, which is it's going to be this solid here, right? This solid here, it's when the copper ions are reduced, which is they gain electrons, these electrons, and they form this deposition of the copper. It's this color, it's this color, it's brownish red color, right? It's a brownish red color of the copper there, right? And I hope it makes sense, guys. Now, in terms of the oxidizing agent and the reducing agent, we know that in this side of the oxidizing agent, this is the oxidizing agent. No. When this is the reducing agent. Reducing agent is a substance that loses electrons. And this one, it's going to be the oxidizing agent. I hope that makes sense. Now let's look at the net ionic equation. When they talk about the net ionic equation, you take the half cells, right? The half cells, and you balance them. So in the reactants, we're going to have that and that. So it's going to be 2Cl minus plus the Cu2 plus, and then arrow, and then it's going to be the product is going to be that and that. So it's going to be the chlorine gas and the copper, right? That's the net ionic equation, right? And guys, what is important, if you look at the color of the solution is blue, and if the copper it's blue, what causes that? It's the copper ions. Now, very important, the copper ions are blue in color. So if the copper is reduced, just like what is happening here, so the copper here is reduced, there's a reduction that occurs there, reduction. Here there's an oxidation that occurs in this side. So if what's going to happen, if copper is, okay, let me not say if copper is, the copper ions are reduced, that means they gain electrons. So the solution will become will decolorize will decolorize, which means they will become less blue, right? They will become less blue. Guys, I hope that really makes sense. That's the decomposition of a copper chloride in a nutshell. That is what is happening there. Guys, if you look in the table there, in the table 4b, the one that is oxidizing, it's chlorine. Chlorine will be here at the bottom. Which is going to be what? 2Cl minus and Cl2 plus 2 electrons. And then you have there at the top at the table 4b, you have the copper 2 plus that is reduced, and then form the copper there. So guys, this one is going to be the reduction at the top, and then an oxidation at the bottom in the electrolytic cell, guys. And the reaction here is what is spontaneous. The reaction is spontaneous. It's a spontaneous. So the reaction that occurs between the two, it's spontaneous. Guys, I hope that makes sense. Cheers. Bye.